Question. DS. In the isosceles triangle ABC, shown in the figure above, line segment AB equals line segment AC. What is the area of triangle ABC? Condition 1, line segment AB equals 10. Condition 2, line segment BC equals 12. Solution. Now we will solve this DS question using the variable approach. DS, 3 variables and 1 equation. Question. Condition 1, 1 equation. Condition 2, 1 equation. DS question with 3 variables and 1 equation. Let the original condition in a DS question contain 3 variables and 1 equation. Now, 3 variables and 1 equation would generally require 2 more equations to solve for the variables. We know that each condition would usually give us an equation resulting in a total of 3 equations, 1 each from the original condition, condition 1 and condition 2. Since we have an equal number of equations and variables, the logical answer is C. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the area of the triangle if line segment AB equals line segment AC. We need to know the length of all 3 sides, or the length of the base and the height to determine the area of the triangle. Follow the second and third step. From the original condition, we have 3 variables: line segment AB, line segment BC, and line segment AC, and 1 equation. Line segment AB equals line segment AC. To match the number of variables with the number of equations, we need 2 more equations. Since conditions 1 and 2 will provide 1 equation each, C would most likely be the answer. People usually feel anxious when solving these geometry questions, but surprisingly, you can find the answer right away by using the variable approach, without checking conditions 1 and 2. Recall 3 principles and choose C as the most likely answer. In the original condition, we need 2 more equations, so it is about 70% likely that C would be the answer. On the actual exam, be sure to pick C. Let's take a look at both conditions together. Condition 1 tells us that line segment AB equals 10. Because it is an isosceles triangle, we also know that line segment AC equals 10. Condition 2 tells us that line segment BC equals 12. In a right-angled triangle, AHC, line segment AC equals line segment AB equals 10. Equals hypotenuse, and line segment HC equals 1 over 2 times line segment BC, which equals 1 over 2 times 12, which equals 6. Using Pythagorean theorem, we can figure out the height of the triangle. So we say line segment AH squared plus line segment HC squared equals line segment AC squared. In the question, we have line segment AC equals 10. Line segment HC equals 6, and line segment AH is unknown height. We have AH squared plus 6 squared equals 10 squared, which simplifies to AH squared equals 100 minus 36, which equals 64. Rearranging, we get line segment AH equals 8. Which is the height of the triangle. We can find the area of the triangle by formula, which is 1 over 2 times base times height. On substituting the value, we get 1 over 2 times line segment BC times line segment AH, which equals 1 over 2 times 12 times 8, which equals 48. The answer is unique, so the conditions combined are sufficient. Good. The answer is C, because there are 3 variables and 3 equations. Don't forget that there is only one answer. Both conditions 1 and 2 together are sufficient, so C is the correct answer. Note: GMAT aspirants should be aware about some widely asked Pythagorean triplet pairs like 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25, and so on, and many more.